guidance. So various activities departments are organizing so that our student can sustain in a global competition. So as a part of that consistency department, today we are organizing one day workshop on Python using statistical analysis using Python. So Python, as we are aware that one of the globally leading software which is used for various purpose, including the statistical analysis also. So on this occasion, I am Dr. Sharad Kumar Nembale. Welcome all of you for this one-day workshop. Today's workshop, we having two young resource person. First one is Suresh Purohit, who is a founder of Thalmas Infotech Kolhapur. So I welcome you, sir. Again, a second resource person is Sachin Bogan, consultant at Qualitative Analyst Pune. So I welcome Sachin, sir. I also welcome our PG coordinator, Dr. DS Jadhav, sir, and my colleague Pritam Mahadik, sir, and Kiran Ghorpade sir, and all the faculties who are joined this workshop virtually. And also warm welcome to all my dear students who are gathered to attend this workshop virtually. Now, I request today's workshop president, Dr. DS Jadhav sir, to guide our students regarding this workshop.
Thank you, sir. Good morning to all. Honorable Dr. B.T. Jadhav Sahib, Principal of YCS Satara. Respected HOD, Dr. H.P. Umap, sir, Head of the Department of Statistics. All my colleagues, Dr. S.M. Nimbale, sir, Madik, sir, Ghorpade, sir, and important is the one of the resource person, Mr. Sachin Bogane, sir, and Suresh Parik, sir. Hello. Corresponding आजचा जो वर्कशॉप आहे तो रिलेटेड टू द पायथॉन सॉफ्टवेअर रिलेटेड आहे. तर याच उद्देशाने किंवा या अनुषंगाने मला एक गोष्ट नमूद करावी वाटते की जे अदर जे पीजी डिपार्टमेंट आहेत आणि करस्पॉन्डिंग यशवंतराव इन्स्टिट्यूट ऑफ सायन्स सातारा ऑटोनॉमस इन्स्टिट्यूटच्या अंडर चालणारं जे पीजी डिपार्टमेंट आहे याच्यामध्ये असणारा एक प्रामुख्याने बदल किंवा फरक जो आहे तो म्हणजे आपल्या इथे असणारे युजी लेवलसाठी डिप्लोमा कोर्स आणि पीजी लेवलसाठी असणारा ऍडव्हान्स डिप्लोमा कोर्स. आता हा ऍडव्हान्स डिप्लोमा कोर्स जो आहे तो हा फक्त आपल्याला इंट्रोड्यूस करता आला बिकॉज ऑफ द ऑटोनॉमी आणि ह्या ऑटोनॉमीचा बेनिफिट हा तुम्हा सर्वांना विद्यार्थ्यांना होत आहे. तर या उद्देशाने माझं एकच प्रामुख्याने म्हणणं आहे की तुम्ही या ऍडव्हान्स डिप्लोमा कोर्सचा तुम्ही पुरेपूर फायदा घेणं गरजेचं आहे. आता सध्याच्या डिजिटल वर्ल्ड मध्ये जर आपल्याला पाहायला गेलं की एव्हरीवेअर ह्यूज डेटा अवेलेबल आहे. सो ह्यूज डेटा अवेलेबल आहे. ज्यावेळी आपल्याला त्या डेटाशी डील करायचं आहे, त्या डेटावरती अनालिसिस करायचं आहे, काय आपल्याला सिग्निफिकंट रिझल्ट फाइंड करायचे आहेत, त्यावेळी ऑब्व्हियसली आपल्याला गरज पडते ती सॉफ्टवेअरची. आणि सॉफ्टवेअर्स म्हणले की मग प्रामुख्याने बरेचसे डिफरंट सॉफ्टवेअर्स ऑप्शन्स आपल्या समोर अवेलेबल्स आहेत. त्यामध्ये काही जे आहेत ते तुम्हाला पेड व्हर्जन मध्ये आहेत, पेएबल आहेत, काही जे आहेत ते तुम्हाला करस्पॉन्डिंग फ्री ऑफ कॉस्ट मध्ये आहे. त्याच्यातील एक फ्री ऑफ कॉस्ट मधील सॉफ्टवेअर म्हणलं की पायथॉन सॉफ्टवेअर प्रामुख्याने नाव पुढे येतं. सध्याच्या आयटी सेक्टरमध्ये जर आपण पाहायला गेलं तर एक शॉर्ट पिरियड मध्ये एक नावारूपार आलेलं सॉफ्टवेअर किंवा जे ऍप्लिकेबल सॉफ्टवेअर कोणतं असेल तर पायथॉन सॉफ्टवेअर म्हणून प्रामुख्याने उल्लेख केला जातो. तर या पायथॉन सॉफ्टवेअरच्या बाबतीत जर थोडंसं जर सांगायचं झालं तर करस्पॉन्डिंग फाउंडेशन ऑफ सॉफ्टवेअर पायथॉन सॉफ्टवेअर डेव्हलपमेंट फाउंडेशन जे आहे त्यांच्यातर्फे करस्पॉन्डिंग ह्याचे कॉपीराइट्स जे आहेत ते पूर्णपणे त्या फाउंडेशनकडे आहेत. आणि पायथॉन सॉफ्टवेअर डेव्हलपमेंट जी फाउंडेशन आहे ती युएसए मधून रनअप होते. सो याच्यामधील काही प्रोग्राम्स काही लायब्ररीज जे आहेत ते तुम्हाला फ्री ऑफ कॉस्ट मध्ये आहेत, परंतु काही पर्टिक्युलर लायब्ररीच्या बाबतीत जर तुम्ही विचार करायला गेला तर थोड्याशा त्या काही पेएबल अमाऊंट्स मध्ये पण अवेलेबल्स आहेत. सो ती सुद्धा निग्लिजिबल गोष्ट आहे. जसं की आपण आर प्रोग्रामच्या बाबतीमध्ये डील करतो तसेच आपल्या पायथॉन प्रोग्रामच्या बाबतीत सुद्धा तुम्हाला ह्या गोष्टी सुद्धा अनुभवायला येतील. तर सध्याच्या इंडस्ट्रीची नीड आणि आपल्याकडे असणारे अकॅडमिक ह्याच्यातील दोन्हीतला गॅप भरून काढण्यासाठी आपण ऍडव्हान्स डिप्लोमामध्ये पायथॉन सॉफ्टवेअर हे इंट्रोड्यूस केलेलं आहे. तर या ऍडव्हान्स डिप्लोमाचा पुरेपूर तुम्ही फायदा घ्यावा. तर या आजच्या वर्कशॉपसाठी आपण प्रामुख्याने बोलवलेले पहिले रिसोर्स पर्सन जे आहेत ते सुरेश परीट सर, त्यांचंही मी पुन्हा एकदा वेलकम करतो. तसेच दुसरे जे रिसोर्स पर्सन्स आहेत ते करस्पॉन्डिंग सचिन बोंगणे सर, जे की आपले ॲल्युमनी आहेत. दोन्हीही आपले स्टॅटिस्टिकल फॅमिली मेंबर्स आहेत. दोन्हीही आपल्याला फ्रिक्वेंटली आपल्याशी कनेक्टेड आहेत. सो त्याचा पुरेपूर फायदा घेऊन तुम्ही मॅक्झिमम नॉलेज आहे ते त्यांच्याकडून गेन करावं. तरेच आत्ता वर्कशॉप हा एक नाममात्र त्यांच्याशी कनेक्ट होण्याचा एक वे आहे. याच्यानंतर सुद्धा तुम्हाला त्याच्या काही इन्फॉर्मेशन जर आवश्यक असेल तर तुम्ही सुद्धा त्या करस्पॉन्डिंग आपले जे आजचे दोन्हीही रिसोर्स पर्सन्स आहेत त्यांना तुम्ही कॉन्टॅक्ट करू शकता. ऑब्व्हियसली ते तुम्हाला ऑलवेज गाईडफुलच राहतील, ते तुम्हाला नेहमीच सहकार्य करतील. तर या वर्कशॉपचा पुरेपूर फायदा घ्या. त्याचबरोबर पायथॉन सॉफ्टवेअरमध्ये जेवढी मॅक्झिमम डेव्हलपमेंट तुमची सेल्फ डेव्हलपमेंट करता येईल तेवढी डेव्हलपमेंट करा. एक सर्वात इम्पॉर्टंट गोष्ट अशी आहे की ज्यावेळी तुम्ही सॉफ्टवेअरशी डील करता त्यावेळी प्रॅक्टिस मॅन परफेक्ट हे जे करस्पॉन्डिंग स्लोगन आहे हे मोस्ट इम्पॉर्टंट आहे. सो जितकं तुम्ही प्रॅक्टिस करणार आहात तुम्ही तितकं परफेक्ट होणार आहे. त्यानुसार जे आता जे काही तुम्हाला ह्या 2 लेक्चर्समध्ये मिळणारं मटेरियल आहे, इन्फॉर्मेशन आहे, त्याचं रिलेशन कधी होणार आहे? ज्यावेळी तुम्ही प्रॅक्टिस करणार आहात त्यावेळी. आणि रेग्युलरली महाडिक सर तर तुम्हाला एक गाईडलाईन करतच आहेत, त्याच्यामुळे तुम्हाला गाईडलाईन मिळतच आहे, परंतु प्रॅक्टिस हा एक महत्वाचा पार्ट आहे. सो तुम्ही ते करणार ही अपेक्षा मी तुमच्याकडून करतो. आणि ऍज अ टीचर तुमच्याकडून अपेक्षा ह्या नेहमी असणारच आहेत आणि तुम्ही त्या पूर्ण करतात, हेही आमच्यासाठी खूप चांगली गोष्ट आहे. तर मी एवढं बोलून मी थांबतोय. पुन्हा एकदा मी दोन्ही रिसोर्स पर्सनचे आभार व्यक्त करतो की ते आजच्या फंक्शनसाठी व्हर्च्युअली प्रेझेंट राहिलेले आहेत. तसेच आपलं गाईडलाईन देण्यासाठी ते उपलब्ध झाले, त्यांनी त्यांचा वेळात वेळ काढलेला आहे, त्याबद्दल मी त्यांचा आभारी आहे. डिपार्टमेंटच्या तर्फे त्यांचं नेहमी चालवेच ऋण राहतील. आणि थँक्यू टू ऑल आणि ऑल द बेस्ट टू ऑल स्टुडंट. थँक्यू.
Thank you, sir, for your valuable words. Now we will move. Now I request Mahadik sir to introduce our first resource person, that is Suresh Parit sir. Over to Mahadik sir.
Good morning, all of you. First of all, I would like to welcome today's resource person for the first session, Mr. Suresh Parit sir. Despite of he is not feeling well, he is with us to deliver the lecture. So I will introduce him in very briefly. So he has completed his master degree in applied statistics from Shivaji University, Kolhapur. Then he joined as the trainee data scientist at the Sintel Pune. He has very good experience in the banking sector, and he has worked with the renowned banking and financial firms such as the Kotak, then Bajaj Finserv, then Axis Bank. Then he started his own organization. Currently, he started his entrepreneur journey. He started the Thalamus Infotech last year, and his organization providing the training for the competitive exams in the statistics such as the ISS, DSO. Also, he providing the guidance to crack the entrance exams such as the IIT JAM, ISI entrance test. So with this brief introduction, I would like to welcome Mr. Suresh Parit sir in our Department of Statistics, Yeshwantrao Chavan Institute of Science, Satara. And now I request him to please deliver the lecture regarding the statistical data analysis using the Python. Thank you all. And I request him to please start with your lecture.
Okay, good morning, sir, and thanks for this is nice introduction. And basically, this is a good opportunity to talk with the students always. And YCI is always organizing such a nice sessions for the students. This is also a very good thing. And as we already know that Python is very useful language in data science or statistical knowledge. But as we are aware about the computing software as a R or MATLAB, even these facilities are also available in Python. Okay. So today we will discuss some hypothesis testing, which we already did in academic. Okay. So just give me a second. I'll share my screen and let me know if you are able to see my screen. I'm audible, right? Perfect. Is
Yeah,
there
yes,
any?
sir.
Okay, cool. So, guys, this is a workshop. This is not a teaching session. So, I need you. You should be more interactive. More interactive in the sense, this is regarding your BSc second year knowledge mostly or third year. This is entirely hypothesis testing and simple one regression problem. So, write down what we are doing. We will solve some problems, but I need more input from you guys. So, it will be more interactive session, and then it will be helpful for you guys. Okay. So, I hope you are aware about what is a Python and all. So, we quickly start with the direct session. Okay, without wasting time. Okay. So, how many sampling distributions you know? So there are multiple sampling distributions. There is a t chi-square here, and all are used to test some kind of hypothesis, right? So whenever, hope you know this setup. This is we call as a Jupyter, and this is a one of the UI framework. At the backend, we can run the R, Python, or Julia. So it's a Jupyter stands for Julia, Python, and R. So you can run any language from this user interface. So right now I'm using Python 3.3 basically version, and here are some markdown facilities and all. So these are the some libraries we'll be using. Okay, and basically we are using this library research py. Okay guys, just note down this, because as a testing procedure we'll be using this, and research py is a pandas data frame. This is a library which produce pandas data frame results, and this will be mostly relevant for statistical testing information and commonly used in academic research. Okay, so as of right now you are not working on too much heavy data sets. For simple statistical testings, you can use this research py. Okay, and this is a good library for testing. So before that, let's start with some testing procedures. So let's say this is the data I am having. Import pandas as a PD, the one of the library for interacting with the data frame. Research py I am also using, and the SciPy stats. So this is scientific Python library, which is having some statistical metrics, and I will be using that. Now here, what I did df is equals to pd dot read csv. This screen is visible, right? Perfect. So is there any, do I need to zoom a little bit or not? I think it's fine. Perfect.
Yeah, it's okay. I think if a student you have the any issue, then you can let us know.
Yeah, please. Okay, so here what I did, I have one data which is regarding blood pressure. Okay, so after seeing data, so I can see df.info. It has these many variables: patient name, then gender, then age group. So in what particular age group they belong, and there is a BP before and BP after. Okay, so blood pressure before and the blood pressure after. Okay, so my data will look like this. So if I'm having this data, oh sorry, actually I need to run this because I have run df several times. Okay. So this is the my data. Okay. So what kind of hypothesis you can test if I have given this data? Okay. What kind of hypothesis you can test? First, so my data has patient this ranking. So this is just for roll number purpose. The sex is either having two values, male and female. There are age group, and then BP before and BP after. Okay, so this is what the data we are having. So if I'm having this kind of data, what kind of testing procedure you will use?
Parity test.
Parity test. Yes, we can use parity test. Why we use parity test?
जेव्हा डेटा बिफोर आणि आफ्टर असतं तेव्हा आपण पीआरटी टेस्ट यूज करतो.
Okay, perfect. So if we are having a before before and after some because of some treatment, and if you want to check the some differences, or is there a statistical significance before and after characteristics? Okay. So okay. So whenever we are testing using parity test, what are the assumptions for the parity test? What are the assumptions
Normality
for?
assumption.
Yeah,
Normality
normality.
assumption.
Yes, the one of the assumption will be your data comes from the normal distribution. Okay, so this is one of the assumption. And whenever you are doing a testing procedure, what you can do, you will only run the t-test, but this is not the true approach or right approach. Whenever you are doing the test, you need to verify that whether your sample came from the that normal distribution or not. After that, there is also assumptions regarding the variance also. What are the assumptions regarding the variance? Is there any assumption on variance? And this is a BSc statistics. Guys, tell me first. First. If you don't tell me, we will don't move further. Okay, you have to tell me. Anyone? And guys, this is not true or false. Okay, you can tell me if even if it is wrong. Okay, fine, we will discuss. But at least speak, because the major problem with our student is that they don't speak. They have everything. They know everything about statistics. And as you did masters in statistics, or you are doing masters in statistics, you must aware all these basic concepts. Okay, fast. Okay, forget about the assumption. We will discuss that later. Okay, now this is the data you have. Is there any test you can also run after that? Okay, pair test. Okay, fine. Any other test? I'm audible, right?
सर नॉन पॅरामेट्रिक टेस्ट वापरू शकतो नॉर्मॅलिटी अझम्पशन नसेल तर.
Okay, we can use normal, yes, non-parametric test also. But right now we are not testing for your normality test. Okay, we are just doing, if we are having this kind of data, what kind of other test you can compare. So why we use tests? We need to compare the differences between the two groups. Okay, or basically a particular characteristic which will be divided by some characteristics. Like if you see here, there are basically two groups, male and female. Okay, so you can also compare the BP after and for male group, and BP after the for female group. Like at least mu1 is equal to mu2 versus or against mu1 is not equal to mu2. Okay, this also one of the test. Yes, the what we can say for that test, significant difference between the two population mean, right? Yes or no? Mu1 minus mu2, sorry, mu1 is equals to mu2 is my h naught, and mu2 mu1 is not equal to mu2 is my alternative hypothesis. Yes, understood? Because if you do understand that, then we can write the code for that. Otherwise, that doesn't make any sense. Okay, so what we can do is, let's just give me a second. Okay, I will attach pair also. So because if you are not aware about the basic parts, then it doesn't make any sense to start with the direct testing procedures, like writing code for it. Okay, so Okay, so basically what we are interested in mu. We can also check this, right? Mu1 is equals to mu2 against h1 is equals to mu1 is not equal to mu2, right? So this can be also a one of the hypothesis, right? And what you are doing here, basically there is a BP after. So what we can do, mu1 is what BP after for male group and similarly for female group, right? Now this is what we want to test. So what we can start with, so this is a pandas data frame. Okay, before that you can use question rp.t test. It will be gives you the all related information, what exactly this data contains, the group 1, group 2, then group name, what is exact name of that group, then group 2 name, equal variances, whether you are going through the equal variance test or unequal variances. Okay, and we will check that also later. Right now what we are doing, so group 1 is my this df from BP after. Okay, so we are testing for this value where sex is equals to male. So this will be giving us entire value for your first group. Okay, so this is a step 1, step 8. So this is my group name, not this, till here. So this is the data which is having information about only male group. Okay. Now second will be if I use female here, that will be giving me data for female. Okay. So now this data will be for female group. Now what we are interested in, whether these two groups are having equal mean for BP after. Okay, so whenever I run t test, I need to write simply rp.t test. Okay, here then group 1 is equals to your the BP after for male group, then BP after for female group, and you can name it because it will be easy for us to interpret the same. Okay, so if I'm writing it, run this, I'll be getting these results. Okay, so if I give you this summary, hope it is visible. So can anyone tell me what you can interpret from this data or this summary only? If I'm giving this information, let's say there is a mean, there is a standard deviation, then confidence interval, and the standard error. So if I am giving you only this information, what you can interpret from this? Fast wise, you have to speak, otherwise that doesn't make any sense. And we have very limited time, and we need to discuss t-test, chi-square, as well as ANOVA and linear regression. Okay, so it will be better if you speak. What you can interpret?
Sir, here p-value for two-tailed test is less than 0.05. Then we say our
No, okay, okay.
hypothesis is
Wait. We will discuss that later. Okay, I only need the interpretation from this. Okay, this table. We will discuss that p-value, other difference values, and all. Okay, I need this summary based on this highlighted area, based on only summary statistics. Okay, what I'll do, I'll just simply got summary statistics here. Okay, based on this data point only. Male is having, so what is the information given in this table summary? How many observations are there?
120 observations.
Yes, there are 120 observations. 60 male, 60 female. Okay, cool. Next, what is the mean of the both characteristics? Basically, mean of the BP after for male and female group. The male group is 155 and female group is 146, and average out it will be 151. So if you see this, you can easily see that there is a significant difference. So how much difference it is, or can we evaluate that? So because sometimes if your data is very lengthy or with higher spread, you can't exactly evaluate this whether it is significant or not. Okay, so it is again dependent on the standard deviation. If you see here, your standard deviation is also huge. So 15 is the standard deviation for this first male data, and 11 is standard deviation for female data. It means that your data has spread, and if your data has spread, this much difference can be a significant enough. Okay, now if it is this is my hypothesis. I think that they are not equal. Okay, now whether they are equal or not, we need to observe from the t-test because it is a good parametric test. So to test results, now test results are this. Now you can tell me what is the result value, and what is the p value, what is the t, what is mean by degrees of freedom, and all these statistics fast. What is mean by degrees of freedom?
Number of independent observations.
Number of independent observation from where or what, for what? Number of independent observation. Okay, fine. We need to add something to that. It will make more sense. So number of independent observation used to define test statistics. Okay. So here degrees of freedom will be 118. Why? Why 118? There are 120 observations and we don't know mu1, mu2. So instead of that, what we are doing there, we will be using sample means, right? So sample mean for first group will be 1 degrees of freedom. We will reduce 1 degrees of freedom for male group and 1 degrees of freedom for your second group. So now that will make n minus 2 degrees of freedom will be 118. Okay. Now t statistics, still t statistic will be this value. Forget about this. What about this part? P value is indicating that is 0.0011. Okay. If my p value is this, what will be my hypothesis or what will be my interpretation from that? Guys, so there are some few students from masters as well, right? After that, if you go to any organization, mostly if you are going for the pharma sector, they don't do that much complicated stuff. Complicated stuff in the sense that they don't use that much deep learning, your mathematical modeling part, then machine learning and part. The most of the work will be done on this testing of hypothesis part. Okay, you have to use most of the parametric test. If the parameters are the you don't have any information about the parent distribution, you will use non-parametric test. And most of the pharmaceutical industry, most of the analysis is done through this testing of hypothesis. Okay, and if they are hiring based if you are looking for candidate for the same purpose, they will definitely ask question related to the testing of hypothesis only. Okay, you know, you did masters in statistics, so they assume that you are aware about this. Yes, you are aware about that. You got marks, good marks for that. Two things are okay. The last point is important, that you need to explain thoroughly to the third individual. Okay, what exactly mean by p value, what exactly interpretation you are giving with respect to that test. Okay, so as here my p value for two-sided is 0.0011. What is mean by that? And you already studied p value, right? So it's not like you don't know p value. You know p value, right? So tell me.
Hello, sir.
So p value
Yes, yes.
So p value is less than 0 alpha 0.05. That's why we reject the null hypothesis and will conclude that the mean blood pressure after group of male is different from mean blood pressure after group of female.
Okay, so when you are showing this value is less than 0.5, so you can use also 0.1 also. Okay, so it doesn't depend on the alpha. You can choose any alpha. Okay, good, no problem. Any other interpretation? Who was speaking? Do you have any other interpretation, or do you want to include something into that? No.
Sir,
Okay, cool. Yes. Yes,
sir,
yes,
my
Kiran.
opinion is also same.
Okay, cool. So when my p-value is this less than alpha, alpha you can take either 0.01 or 0.05. 0.5 is quite huge error. Okay, so 0.5% no one can tolerate that much error. So 0.01 1% error. Okay, okay. Still people sometimes choose this much of error 0.001. Okay, but fine. This will be also okay. And as we interpreted that they both are different. Okay, this is okay. If you go here, what you can see from the intervals, the first interval will be 151 to the 159, and second one 144 and 150. So this is upper limit or upper ninth 95 percentile. Okay, right? And this is 95% for this. So it from here you can easily understand that there is a no that much overlap between these two intervals also, right? So from here you can easily understand that the intervals for 95% confidence, they are not that much interacting with each other, so they are not non-overlapping. So from here you can easily understand that yeah, there is a significant difference between first group and second group. Okay, so what will be the interpretation? The average blood pressure after treatment of our main is this, and the confidence interval is this, was statistically significant. Okay, and what is the significant? Higher than. Okay, because you can see here the 155 and 147 are the values. So it means that your first group is greater than second group. Okay, the characteristics. Okay, now next. Basically, what we discussed is before that, your data must came from the normal distribution, right? Now what we are assuming here, or what we are testing here, x bar minus x2 bar, and that will be having normal distribution, right? Yes or no? So here, what is my testing procedure? Actually, this board is not that much good. So x1 bar minus x2 bar divided by, let's say, whatever its standard error, and this will follow your t. No, not this will be follow, that will be different. But if I want to define that, this will defining the test based on this should follow normal distribution with some parameters and some sigma, right? Yes or no? So x bar, what about, I need to check that na, ki whether this x bar minus x2 bar, whether it follows normal distribution or not. Okay, so what is the, how we can test that, whether that x bar minus x2 bar follows normal or not? What we can do, there are multiple ways we can identify that whether this follow normal distribution or not. What we can do, first will be what, fitting of distribution, right? You can do fitting of distribution. What else you can do? I can obtain normal probability plot also. Yes, what is meant by NPP, normal probability plot? Have you studied that? Yes, no? आता शिकलाय की नाही?
Yes, sir.
हा, मग काय शिकलाय ते सांगा ना. What is meant by NPP, or what it indicates? It will gives us, if the data points fall in this line, it will indicate that your data comes from the normal population. Okay, so we will use that visualization approach, because whenever you are doing a assumptions, okay, numbers are that much not good enough to understand. Okay, instead of that you can visualize the data and you will get better understanding about your data itself. Okay, so whenever I am saying your normal data fitted well with p-value this, okay, instead of that you can simply put histogram, and if it will look like normal, you can say that your distribution is normal, right? So visualization is also good area where you can explore your visualization as a career option. Okay, and there is a huge demand for visualization also. You can use, there are lots of softwares. You can work on Tableau, then ClickView. There are good libraries in Python are also ggplot, plotly, okay, interactive dashboards, okay. And don't only run for the data science job, okay. There are huge opportunities and diversified opportunities for statistics students, okay. Someone who is interested in visualization part, you can work on this softwares also, just for an understanding, okay. So now what, also I will obtain the sample means for the same observations. So I obtain here dp for the values, then dp for values. These are the two values which got from the sample. Now what I'll put, I will obtain the normal probability plot using stats. The stats with the scipy library. So normal probability plot and stats, which is equals to stats dot probability plot. Then sampling difference, I'll be obtain values from the sampling difference of actual values. Then plot of PLT, because which is what we want. Then reevaluate it's true. Now axis will be what the entire thing, and if I show the plot, it will give us normal probability plot, okay. So normal probability plot will look like this. So after seeing this is the ordered values, and this is theoretical quantiles. And if you see this, it looks like all points are fall on that line, okay. It's not giving us an exactly pattern like yes or some other patterns, but if you see all data points are on this line, it means that your sample came from the normal distribution, okay. And you have to do this kind of work, okay. Whenever you are assuming something, verify the assumptions, okay. Now next will be the homogeneity of variance. This is also one of the assumption while we are doing t-test, okay. Now what, there is a test 11 test to check whether that is whether the homogeneity is present or not about variance. You can just simply type this data and put the center is equals to mean, it will give you a result. Again this will be point not one, okay. So based on the p-value, the test signifies significant, which indicates that group have different amount of variation, okay. See here, so my this is my h naught will be sigma 1 is equals to sigma 2, but here what is what we got p value is this, so it means sigma 1 is not equal to sigma 2, okay. And have a difference amount of variation, and that the t-test may not be a best theoretical approach to method to be used, okay. So you have to be make sure that whenever what are the assumption you have made, they must you have to follow them, or follow them means you have to check them or validate them. Again this is just value, right? I can't understand point not one is there, so how much variance is there, I can again plot the data and I can understand that, okay. So plotting here what we did, I got the, I'll plot combined histograms for two data sets, okay. And if I plot this combined data histogram, it will look like this. So distribution between past and this, hope it's visible, right? Let me make it a little bit smaller here, okay. So this is the one male group and this is a female, sorry, this is a male group blue, and this is something I think gray or orange something. So see here, the sigma for here is 15 by 2. Sigma is 11.7. Obviously they are different. So we can't use sigma homogeneity. The homogeneity test is failed here. Okay. So you can visualize this and understand whether my assumptions are correct or not. Similarly, you can do purity test with simple, only change will be now you have my first group will be the before and second group will be after. For the same group, male sex group is male and sex for female, and you have to use here purity test. It's instead of true it's purity, then it's true. It will be giving us respective here this. So here also, what is p value? P value is this. What is mean by that? P value is 12 here. So what we are saying here? guys. If p-value is 12.81 for again this same parity test, what is mean by that? There is no significant difference, right? No significant difference between your before and after group. Basically, if you are adding some or doing some method, that doesn't impacting on your actual status about that BP. Okay, so from here there is a no significant difference. Now next test will be chi-square of independence. What it does, the chi-square test of independence will be used to check whether there is a dependency between two groups. Okay, two or more groups. Basically groups means categorical variables. Okay, so this is what the data we have. Okay, so division region head sorry, heat TDD, then cold DD means daytime heat, cold time heat, sorry, cold, what is the temperature, then temperature in Jan, temperature in July, and age category. Okay, these are the variables we are interested in. This is the data. So how we do the chi-square test for independence, or can you anyone construct the hypothesis for this? Because in an organization they don't ask you guys to run this independent test on this data. They have given this data, now you have to create your own hypothesis and validate those. So if I given you this data, what kind of independence hypothesis you can do or create? I need that hypothesis. Tell me. Okay, this is the data you have, these are the categories, the variable names. So this is age category is your categorical variable, region is categorical variable, then division is categorical variable. Okay, think about it. Okay, just give me 2 minutes, I'll back. Okay, I'll attach the charging point for this. Okay, think about it. Okay, sorry guys. Yeah, tell me. Fast. Guys, anyone? Basically, when we use chi-square test, it will be used to check whether there is a dependence between the two categorical variables, right? So I need to check whether these two characteristics are dependent or not, or how we do that, guys. This is a pathetic. Okay, you need to explain this quickly. So if I'm having data sets like this, the first group, let's say there will be having category A, B, then C, then here let's say C1 and C2. Then this will be your data points respective. Okay, counts, right? And this will be your total n will be here. And from this, what you can obtain OY minus EI, and that will be from here you can obtain the chi-square of independence, right? Yes or no? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
So you already know this, right, guys? So why you haven't tell me? Because you wasted 5 minutes. So what is the procedure for this? This is actual values, right? So this will be, let's say 4, 9, whatever the values are. We will discuss that then later. So these are the some values. Let's say it's 10. This will be 40, 12, and this will be 18. Something this. Now this will be the sum of this will be here. Sum will be here for row wise sum here. Column wise sum will be here. Row wise sum will be here. These are the actual values. Now expected value will be what? This into this divided by this, right? That's how we calculate the expected values. No, I think this into this will be your expected values, right? Yes. How we calculate expected values, guys? And is there any assumption about this? Okay, so what are the assumptions for chi-square test? Not exactly assumptions, we can say. We check some something, right? So your expected frequency shouldn't be 0, or it shouldn't be less than 5%, right? So we also need to check that. So right now, let's say we'll start with, I'm interested in age category because this is a categorical variable and this is a region. Okay, so this is what we got. The summary for age category and region will look like this. So this data having age having these three groups, and region is north, central, west, south, and northeast. And these are the respective count and frequencies. Okay. Now, if I get cross tab like this, okay, because we need cross tab for that, right? So if hope you are able to see this cross tab. Can you interpret something from this, whether these two groups are independent or not? No, right? Because there are huge numbers, you can't easily understand or compare that. So that's why we will go to this cross tab rp dot cross tab, and this will be your calling cross tab, then test results and expected value. So rp dot cross tab df of region, so it will give us region value, then df for each category, then which test will be using here, chi-square test. Expected frequency, yes, we want that expected frequency because it will be used to check whether is there any zero frequency or not. So my final frequency will be this cross tab, which we already got, right? So this is my 53.03%, then 17%, then 100%. This is, and test result will be look like this. So if my t test is this, p value is this, what is mean by that? P is 0 means what? What is your null hypothesis for chi-square test? Guys, what is a null hypothesis? Even you do regression analysis and all the complicated stuff, you have to again go for these testing procedures while testing that beta parameters, individual parameters, right? So you must aware about all these sampling distribution tests. Okay, if you are not, just go through the again read the basics from your second year notes, okay, and your MSc first year inference. I think that don't contain these procedures, but they will be having some advanced tests or MLE options and all. So if right now, what is our hypothesis, guys? Tell me, what is the interpretation from this?
Do categorical variables are independent? H not.
Yes, yes. H naught is those are independent. Now my p value
Mhm.
is zero. What it indicates? We will
Rejects,
reject the
reject,
alternate.
reject, reject.
Yes, reject null hypothesis. It means that they are dependent, right? And
Yes,
again, the
dependent.
important thing they are given, yes, they are given this Kramer V. Okay, so Kramer V is not only used here. Okay, whenever you are going for the logistic regression also. Okay, if there is a categorical variable, because let's say we are doing binary regression or multiple categories classification, multi-class classification problem, and let's say there is a one individual independent variable. At that time, you need to calculate this Kramer V to check whether there is any dependency between them or not. Okay, so Kramer V is also got 0.179. So Kramer V gives this interpretation. If Kramer V is 0.25, it's very strong. Greater than 0.15, it's strong. So from here you can easily say that this Kramer V is 17 greater than this 15. So there is a strong relationship. It's not like there is only relationship or they are dependent. There is a strong relationship between them. Okay. Now assumption check will be only the no expected cell count will be 0 and no more more than 20% of the cell have or expected cell less than 5. Okay, so expected will be always greater than 5. So if you see here, yes, they all are greater than 5 and no cell count is 0, expected cell count is 0. So yes, that is quite pretty much good observations or good result. So we can go ahead with that. Now next part is ANOVA. When we go for ANOVA, and what are the assumptions for ANOVA? You studied it, right?
Compare more than two.
Yes. To compare more than two means we will use ANOVA because it's quite hard to compare that in your T test. This is generalization of your T test. Okay. So in ANOVA, one way ANOVA, what we do here. So basically, what are the assumptions again?
Normality assumption.
Yes,
Sample
normality is there.
independence.
Sample independence. Okay. What else?
Variance same.
Variance. Equal variance.
Variance
Okay.
equality. Mm.
Okay. What else? Okay, fine. So if I'm having ANOVA, what will be my test statistic? There, test statistic. What is the test statistics? How you run this ANOVA test? Can anyone quickly tell me what you follow, what method you are using in a one-way ANOVA? Okay, fine. So we will use the treatment sum of square, residual sum of squares, and total sum of square. The treatment divided by respective degrees of freedom will follow what chi-square distribution. Again, the second will also follow chi-square distribution. Then treatment divided your residual sum of square will follow. The respective degrees of freedom will follow F distribution, right? Because it two are chi-squares, and chi-square independent ratio will follow F distribution. So we'll be using F statistics. Okay, and what is the range for F? What is the range for F? Range for F, guys.
0 to infinity.
ओके कूल. एवढा वेळ लागतो का रे तुम्हाला? Okay, so these are the three basic assumptions. First will be population distribution are normals. Sample will have equal variances, and third one will be the independence between these samples. Now this is the data we are having. Okay, this is basically actual data regarding your treatments. Okay, there are three different treatments. One will be the placebo effect, then low treatment, and basically low dose and high dose. Okay, and we need to check whether these doses are impacting on any particular characteristics. Okay, so this is the data which we have, and it will be got from this GitHub raw data sets from the GitHub. Now this will be having these data sets. So libido is the one characteristic we are looking for. So we will check that, and dose is another one. So dose is having three doses. First one is placebo, second will be the low dose, and third will be the high dose. Okay, understood the data set. Now we are checking whether these doses are impacting on this libido. I don't know what is meant by libido. Just search what is meant by libido. 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 Whatever it is. Okay, so basically these are the data from this one research, and these are the points. How many observations are there? Now what next will be? This is a summary. Okay, group by summary. So if I'm having summary before going for any testing procedure, try to run EDA. Okay, exploratory data analysis. So if I'm having this data, what you can interpret from this data? What is the mean? What is the dose and their respective mean? And your standard deviation, again confidence interval for that. So if I'm having this data, what you can interpret from this? First, tell me guys, what you can interpret? What we are doing here, basically, we are trying to compare mu1 is equals to mu2 is equals to mu3, right? In t-test, we are only interested in mu1 is equals to mu2 versus mu1 is not equal to mu2. And here what we are interested in, mu1 is equals to mu2 versus, mu1 is equals to mu2 is equals to mu3 versus one of the inequalities there. Okay. So from here you can easily see that your mu high for high dose mean is 5. For low dose its mean is 3.2, and placebo effect it is mean is 2.2. From the data itself you can easily understand, yes, there is a significant difference. Okay. Now we want some evidence. Okay, so to get those evidence we will run the ANOVA. So ANOVA will be this. Yep, one way, because we want one way test. Yep underscore one way stats dot, it will came from the this pi stats library stats. Then your first data with respect to this libido for dose is equals to high, then libido is equals to df, dose is equals to low, and placebo. Now this data has given me p value is equals to this, and test statistics is this. So forget about the statistics, just focus on the p value. So if my p value is this, what is the interpretation from this?
Reject note, sir.
Reject or accept? Okay, if you are using alpha is equals to 0.5, okay, fine. We can reject null hypothesis. If I'm using 1% level of significance, then accept. Okay, so again, this will be dependent entirely on your alpha. Okay, so yes, if I am using 5% level of significance, we can reject the null hypothesis. It means that there is at least one there is no significant difference between all these treatments. Now, here what we use stat is equals to f one way. Then also you can run the same with the help of this stats model, a formula IP with the OLS estimation. What the OLS stands for? Ordinary least squares. Okay, so whenever you are doing ordinary least squares, what we are doing there? What is the method? So if you do this, you will be getting similar kind of analysis here. Okay, the only challenge we are facing where you will be getting some NaN values, and it will be quite not easy to interpret those. Okay, instead of that, that's why we use F one way. Okay, and this will be, you can understand, at least get this p value and all. Okay, just for understanding, you can go through it. It will be easy for you guys to understand. And next will be same. What will be we are interested in? Obviously, we'll be interested in normality assumptions. We made the test, we also give the interpretation on the test, but when it has to follow their assumptions. So first will be normality assumptions. So to check normality assumptions, we'll again plot the normal probability plot, then stats, then model which is already stored here, ordinary least square model, residuals. Now what we are plotting here, the residuals of that model, and if residuals follows the normality plot, okay, means they are, if they are lying on that linear line, it means that your model basically data came from the normal population. Okay, so if I to plot this, these are the simple statistics. You can import matplotlib.py plot, then figure is equals to this. These are the basic syntaxes for matplotlib. Okay, normal probability plot is equals to and stats, because we are storing both information, is equals to stats dot probability plot model dot residuals, because we are interested in the residual probability plot, and we are interested in output as a plot. After showing this, my normal probability plot will look like this. Now if you see this, as we are having only less number of data points, okay, it will be giving us r is equals to 0.03. It means that your line is fitted well. It seems like it came from the normal distribution, but I am not sure. Because why we are not sure? If you see here, there is a not pattern around this line. If you see, this is something like spherical or wave like structure entirely. This is wave, again one wave, again one wave. Okay, so even if it is r square is equals to 0.93, okay, this doesn't look like your normal priority plot. So all points not on this line, so we can't say about any normality session. Okay, so this will definitely help. If you, I only just plot this and I will get r square is equals to this, what you can say, yeah, there is a normality. But if I plot this data, I can see this is the structure, so we say that we are not following normality here. Okay, also you can check the Levin's test. Levin's test will be giving also this information, 0.89 means there is a normality. Okay, sorry, Levin will be used for this will be done with for a normality assumption. Levin will be used for there is a what equality in variance. Okay, and it will be showing us, yes, there is a equality in variance, because p value is huge means 0.89, that is something huge obviously. Now 0.89 is okay, but instead of that, what we can do, again plot the data, and it will be easy for us to interpret. So 11 will be used for 11 test stat.11. You can get the data for respective treatments and the libido value. Instead of that, you can also plot box plot. Why we plot box plots? And what is the usage of box plot? Can anyone tell me why we
Outlier
use box plots?
detection.
Summary of mean, median, mode, range in one picture.
Okay, so everything you can, the five point summary, so you can easily get. Okay, If I plot multiple box plot together, I can compare to different populations. And again, important part will be this box plot will be giving us a good measure of dispersion. Dispersion means the variability in our data. So again, we are interested in the same, right? We want to check sigma square is equal to sigma 1 square equal to sigma 2 square equal to sigma 3 square, right? So if I plot the box plot and if they look like similar, we can say that yes, there is a similarity. So here what we are doing, we are also plotting the box plots. Data is equals to this. Now x dot box plots of the data for placebo, low and high. And if you plot this, I can see the box plot like this. So if you see this, the spread of this data, this and this, okay, they are nearly equal or looks like they are similar only, right? Yes, you can see this, right? Wait, just give me a second. Okay, sorry guys. So if you see here, this is the variation among the three data points, like three doses, placebo, low dose and high dose. And from here you can easily see this is the variation explained. Okay, and for every group this is a similar. Okay, right, sorry, actually I have one another. Okay, sorry guys. So this is the placebo variation, this is this variation and entirely looks like similar. So your homogeneity of variation assumption will be satisfied. Now next part will be linear regression, and we will spend so much time for this. So what is meant by regression? Why we use regression? You studied regression, right? Yes, no. Right. What is the regression?
Regression is a method to determine the relationship between one dependent variable and more than one independent variables.
So this is first will be to check linear dependence between your one variable y and x1 x2 dot xn, whatever it is, or simple one only time being. And what else? After building a relationship, we can it will be use that model to predict something. Okay, cool. So what is my model? If I'm using this, y is equals to beta naught plus beta 1 x1 plus epsilon. And what are the assumptions for while building this linear regression? What are the assumptions?
Relation between response variable and linear.
Yeah, there is a relationship, a linear relationship between your regressors and response variable. Okay, perfect. What else? Second, third, four, five.
And
Is there any errors? Okay, errors are what?
correlate.
Normally distributed.
Sorry, errors are, yeah, someone told something. Errors are what, guys? You are,
Independent and normally distributed with
yes.
zero mean and sigma square standard deviation, standard error.
Okay, so if E is something like normal with 0 and sigma square, and if it's sigma, instead of you are saying independent, so I can simply use IID with normal mean 0 and sigma is constant. So from here, I can say that expected value of EI will be 0,
Zero.
expected value of EI and EJ will be also 0. Then variance of EI is constant across also sigma square. Okay, so all these three I can write simply in the single sentence. So that will be fine. Now, these are the assumptions. So whenever I am defining or doing a regression analysis, again same thing, that whenever you build the line or build this regression line, you need to verify these all assumptions. Normality you can use through the NPV plot. This stability of variance also you can check with your same that 11 test or something, or you can use visualization method, no problem. Okay, but this has to be satisfied, and basically your regression will be your expected value of y given x1 x2 dot 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 xn. Okay, because we are interested in the average parameter value. Similarly, let's say we have this data. Linear regression will be used to test the relationship between the independent variables and the continuous dependent variable. Important one will be the, it should follow continuous, your response variable must be a continuous variable. Now this is the data we have. DF is equals to SM dataset wave use auto, and DF is equals to DF input. Now my data has these many variables: make, price, MPG means mile per gallons. Then hope you remember know this data set, right? And this is a well-known data set for regression. Now next will be, I'll be interested in RP. So whenever you have a regression problem, how you will start with, basically we need to identify, build the relationship, right? So to build relationship, my I'll what I am doing, I'll be trying to identify the relative predictors. Okay, let's say if I'm interested in predicting MPG, what I will check, what are the related features or independent variables that will impact on this value, expected value of MPG, average MPG value. So if the weight of that car is higher, it will be impacted by MPG. What kind of, basically weight, engine quality or engine, and then made of means whether different. If the manufacturing units are different, the manufacturing units, okay, they are either in different countries or with a different material, whatever it is. Okay, then similarly for all this. Now whenever we have data, let's say this is y and x1 x2 dot 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 xn. Before doing directly going for the model, instead of that what we can do, again run simple EDA. Okay, exploratory data analysis. So what kind of exploratory data analysis you will do before regression analysis? Obtain the correlation coefficient, that will be also one of the good thing, right? Also obtain the group means for that values. So here what we are doing, we have two values. One is weight and second one is mpg. Okay, so now what we are did here, we got the respective summary statistics. Okay, now from here we can see the both are 74 counts. The mean for this data will be 3019 and mpg will be 21 and sd will be this and this. Now my first observation is that I thought that this made is making some impact. Okay, so whether it is a British made car or some other country. Okay, so if you see their German cars are pretty much very well. Okay, so if the manufacturing unit is different, whether there is impacting on mpg or not. Okay, so instead of that, what I can do, I can simply plot the summary statistics group by with the foreign is the one of the factor. Okay, after plotting this, I can see the summary statistics like this. So is there any difference in domestic and foreign? So now domestic having 52 values, this having 22 values, the respective mean for mpg will be 19 and 24. Okay, so it means that your foreign is for foreign vehicles your mpg is higher and for domestic it is quite less. And if you see here, their confidence intervals are non-overlapping, perfectly non-overlapping, 95%. So it means that yes, there is a significant, it may impact this foreign will be impacting on your response variable. Okay, so what we can do, we will select this foreign variable as a one of the independent variable. Okay, and obviously this weight we will consider because as the weight increases it will impacting on the mpg. Okay, so right now we'll building only regression model based on two variables just to understand. Okay, now what we're doing, import stats model by formula.api. Okay, smf. Now fm smf.ols. Ols stands for ordinary least square, right? So what are the properties for ols? You know, if I'm doing regression analysis, or what is the olc? OLC stands for ordinary least square, where we try to minimize this S beta, okay, which is a sum of squares due to residuals, not residuals, basically sum of squares, and we will try to minimize this. And what is the estimates for beta at? Basically, we are interested in building this relationship, right? So y is equals to beta naught plus beta 1 x1 plus let's say beta 2 x2. Okay, so as we know that x1 is known, x2 is known, we want this beta at beta naught, beta 1, beta 0, so we can obtain the estimated value for y. Okay, now to get this beta naught, beta 1, beta at, what is my beta at? Beta at is something x prime x inverse x prime y. This is the solution got from the OLAC. Okay, and this is the, if this is the solution, what are the properties for OLAC? Estimate, basically beta at estimates. They are also MLEs, right? Also unbiased estimator. What else? Second year, you studied this, right? MSc second year. Guys, what we are discussing this because we need to check this, okay, or whether this is satisfying or not. Again, assumptions, okay, we will discuss that, normality assumption and all. And this is also, OLS is also blue. What is mean by blue? I think you can tell me at least this. What is blue? Based linear unbiased estimator. So beta at is having lesser variance as compared to the other all linear unbiased estimators. Okay. So this is all history about regression analysis. Now let's go back to our example. So whenever I'm fitting OLSC, it will be trying to minimize that residual sum of squares. Now my result will look like this. Now you have to tell me, sorry. Now you have to tell me the results or interpret these results fast. How we check whether model is fitted well or not in regression analysis?
Using R square.
R square, right? So R square is value what? This 6.663. What it indicates?
Accuracy of model is 66%.
Accuracy of model is 66%, means we are able to capture 66% variation through this your x1 and x2. Okay, so it indicates that your model is okay, not that much bad, but in real life scenario 66 also is good accuracy. Okay, people are not able to achieve that much accuracy in real life. Okay, so okay, fine, R square is this, adjusted R square will be 0.65. If you see this, there is a lesser adjusted R square here. It means that they are not equal. There is something dependency between that. Okay, because domestic and foreign are complement of each other, so we have to use one of the characteristics. Okay, we don't use both characteristics. Okay, C combination. So you can understand that while studying this. OLSC, which method we have used, this square. You can use multiple methods. You can use OLSC, you can use any other method also. Okay, so that is also that part. And then after that, if it is good, then we will move ahead with this individual testing. So if you see here, what is the weight coefficient is 0.006, and what is their respective probability 0.00 theta. This is 0. What it means? You studied this, right? Yes or no? At least tell me. If you are not, then I can explain. Otherwise, you tell me, because you are wasting guys too much time. Okay, so there is a hypothesis called Durbin-Watson is test result is this. Then Jacobora also there. You can only check this Durbin-Watson. So from here you can easily interpret the standard errors assumes to be covariance errors are covariance matrix of the errors. It's correctly satisfied. We will check condition number later. Okay, I mean just focus on this. So if it is this, means we are testing here coefficient beta is equals to beta naught, and what is the significance of that? Okay, so it indicates that weight is significant. Okay, intercept is also significant. And about this foreign, I think there is some challenge for efficiency of this foreign category. Okay, now what is the one hypothesis also that their x1 x2 xn are independent with each other. X1 x2 dot xn are independent. There is a no relationship between them. Okay, because we are trying to capture the variation through the n independent characteristics or lesser than n number n characteristics. Okay, so then what we need to do, we need to either check this, is there in a relationship between this, and if there is a linear relationship, we can call this problem as a multicollinearity, right? Yes, and if multicollinearity is there, how we check whether this multicollinearity present or not? अरे रिग्रेशन झालाय की नाही ते तरी सांगा, MSc सेकंड इयर. MSc सेकंड
झाले सर.
झालंय, मग सांगा मल्टिक्युलॅरिटी म्हणजे काय, कसं चेक करायचं. MSc ला आलाय तुम्ही.
सर
सॉरी, तुम्ही आणि 2 महिन्यानंतर जॉब अप्लाय करायला जाणार आणि हेच क्वेश्चन तुम्हाला परत इंटरव्ह्यूला विचारणार, त्यावेळी काय सांगणार आहे, मला 70% पडले आणि 80% पडले. कोण विचारत नाही पर्सेंटेजला. So multiplicative we will check with the help of VIF, variation inflation factor or variance inflation factor. What is the formula for VIF? आता हेच सांगितलं नाही तर VIF चा फॉर्म्युला कोण सांगणार म्हणा, which is equals to 1 upon tolerance, and 1 upon tolerance is something 1 upon r square, whatever it is. I think near about, I even also don't know. Okay, so obviously we need to check VIF if there is a linear relationship between that or a condition number. What is meant by condition number? At least tell me that. Condition number. Have you studied this? Not conditional, condition number. It will be something like lambda max divided by lambda. Lambda is your lambda max is your eigenvalue, maximum eigenvalue. Because your x1 x2 are in a matrix form with they are explaining some variation, and lambda is what, this lambda principal component, first principal component, it will be linearly, basically it's a linear combination of your x1 x2 xn, right? And if it is maximum, okay, it means that your lambda max will be higher and lambda minimum will be lesser. Okay, so this proportion will get higher, and if this is the case, and we are calling this ratio as a condition number, and if this value is higher, it definitely means that there is a linear dependency between your x1 x2 xn. And hope you have studied this in your regression analysis or PCA. Basically use of PCA is this. Okay, so we will check PCA and condition number both here. It will be easy to obtain because there are lots of method available for that. From the stats model, stats outlier influence, you can import the variation inflation factor, and the same model you have to just create the data into this data matrix, D matrix form. After putting this, you can simply run the variation inflation factor on x and y. Okay, and it will gives you the value for VIF. Sorry, so VIF will be look like this. Sorry. Okay, so VIF will look like this. So from here you can easily understand that this is also fine, this is also fine vector, but this intercept is something not good enough. So why intercept is not good enough? Because I think there is some challenge with this. Okay, now we will evaluate this with the eigenvalues, this condition number. So to evaluating collinearity using the condition index, the eigenvalues is also used. Okay, eigenvalues means principal component only. Also can be calculated and collinearity diagnostic will be produced. So again I need to that matrix form because I need SVD decomposition. Okay, so you can use this singular value decomposition with the help of NP Lagrangian single value decomposition. From there you can just simply write this code. Sin x will be giving you the maximum of the lambda 1, okay, and divided by n, and the condition number will be attached. So condition number will be look like this, 1.588 and this. So if you see here, this number is quite huge. Huge means this is not acceptable. This ratio is quite higher, and from here you can easily understand that there is a relationship between your x1, x2 and xn. Okay, and that's it for today's guys. Do you have any question for me?
सर मल्टिकोलोनिटी रिमूव्ह करायची असेल तर त्यात आता
सॉरी, मल्टी क्वालिटी रिमूव्ह करायची असेल तर मल्टिपल वेज आहेत. एक तर तुम्ही असं करू शकता की ज्याला हायर जो रिलेटेड आहे तो कन्सिडर करू शकता. ओके, सो यू विल सिलेक्ट द वन विच इज हॅव्हिंग हायर इम्पॅक्ट, or you can include the linear combination between that two variables. That is also fine. Also you can run that PCA analysis, so it will be used as a dimension reduction technique. Instead of your x1 x2 you can use a linear combination, so your principal components are linear combinations also. Okay, or you can run PCA and got the respective eigenvectors and use the variable which is having a higher eigenvector value. You can use any one of the method. There are lots of methods.
ओके सर.
Anything else? Okay, so this is so sir, how much time we have?
Actually, we can stop now. If you are over, then I think Sachin will
Yeah.
join.
Okay, I'm done with the part. Guys, if you
Okay.
have any questions, you can ask me. If you have 5 minutes more. Right? I think I consider it as there is no questions. Okay. And thanks for this good opportunity. Guys, best of luck for you all for your upcoming journey also. And thank you. Thanks for this nice opportunity. Okay. Thanks, sir.
Okay. Actually, I would like to thanks Suresh Parit sir for accepting our invitation in very short time period and deliver us very good lectures. So actually, today he is not feeling well. Still, he committed us to give the lecture and he delivered the very good lecture. For me, it is always a good opportunity to listen Suresh Parit sir and learning new things. I have always listen their whole lecture. So I have attended 3 lectures in YC Institute. अ, ज्यावेळेपासून मी जॉईन केलेलं आहे वायसी इन्स्टिट्यूट त्यावेळेपासून परेड सरांचे मी 2-3 लेक्चर अटेंड केलेले आहेत आणि कायम माझ्यासाठी ती एक लर्निंग अपॉर्च्युनिटी असते आणि आपली कायमच ते इन्व्हिटेशन ऍक्सेप्ट करून लगेचच जे काही लेक्चर्स आहेत ते डिलिव्हर करत असतात. सो आय वुड लाईक टू थँक्स फॉर दॅट and I hope in future also we will get the same cooperation from him. Okay, thank you for it, sir.
Yeah, thank you, sir.
Okay. Uh, and now I declare that our first session is over. So now we are going to start our second session. So Sachin Bogan sir, you are joined, right? Sachin, am I audible, Sachin? Okay, I think he had joined, but it looked like he has some issue. He will join in some time. Okay, we will wait for some time. I will call him. He will join soon, and then we will start our second session. ओके, आपण आपला सेशन जो आहे ते 2 ते 3 मिनिटात स्टार्ट करतोय. सर जॉईन होत आहेत. तोपर्यंत तुम्हाला जर काही क्वेश्चन्स असतील तर तुम्ही विचारू शकताय. मला वाटतं परीट सर अजूनही जॉईन आहेत.
Hey, hi Ritam. Am I
Yeah,
audible?
good morning. Yeah, yes, good morning.
Hey, good morning.
Okay.
Good morning.
Guys, we will start with our second session. So, resource person for today's second session is the Mr. Sachin Bogan sir. I welcome him on the behalf of Department of Statistics, Yashwantrao Chauhan Institute of Science, Satara. So, I will introduce him. He has completed his master degree in statistics from our institute. Then he worked as the assistant professor in our institute. So he has the he was the student here as well as the teacher in our institute. Then he joined the MIT Institute Pune as the assistant professor. Then basically he worked as the quantitative analyst at the CRISIL. Currently he is working as the consultant quantitative analyst at Solitics Partners. Also he is pursuing his MPhil degree from Shivaji University, Kolhapur, under the guidance of the Honorable Vice Chancellor Dr. D.T. Shirke sir. So with this deep introduction, I would like to welcome Sachin Bogan sir in this one-day workshop on Python software. And now I'm request him to please start with your lecture.
Thanks, Ritam. Thanks for introduction. Okay. So, hi guys. Hello. Hello.
Yes, you are audible, Sachin. You can proceed.
Yeah. Yeah. Thanks. So, guys, I think we have workshop on Python. Okay. So I have seen your invitation in that. I think you have mentioned rightly that we are how we are going to use Python in data science field. So guys, currently I am working as a consultant quantitative analytics team of Solitics Partners. Okay. So I will not go much deep in data science because the data science is very broader field where we have different algorithm, different techniques which are included in this field. Okay, so just letting you know that data science is not related to only a statistics. Okay, there are multiple fields from which we are going to combine the algorithms which we used in data science field. Okay, so just to know about the audience, I have some quick questions on or some case studies for you. Okay, so let me ask you a few questions. Okay. Okay, so let's suppose that guys, you are a data scientist who've been recruited to help to detect fraud during college admission process. Okay, so now you need to tell me what are the key attributes that you are going to consider and what models that you are going to build on such data. Anyone? Guys, are you getting my point? I'm having one case study where you are recruited as data scientist, and you have to detect fraud in admission process. I wanted to know what are the key attributes that you are going to consider on the side of this problem, and what are the models that you are going to build on such type of data. Speak up, anyone, guys? Hello, are you getting my points? See guys, if I don't understand the audience what I am having, okay, I can't deliver my lecture. Okay, so that's the reason why I'm asking the case studies. Okay, anyone can answer. Sorry, I don't have any response, guys. Can I pick someone randomly? Hello. Yeah, guys.
सचिन सर, यू आर ऑडिबल. स्टुडंट, त्याने एक तुम्हाला यूज केस विचारलेली आहे, त्याच्या रिलेटेड जर तुम्हाला काही आन्सर देता येत असतील तर प्लीज द्या. जर तुम्हाला माहिती नसेल किंवा काही सुचत नसेल तर तुम्ही आन्सर माहिती नाही असंही सांगू शकता. फक्त तुम्हाला बोलण्याची गरज आहे. जे काही तुमचा आन्सर असेल, वेदर यू नो समथिंग देन टेल व्हॉट यू कॅन डू, अँड इफ यू डोंट नो देन जस्ट टेल द नो. इव्हन तुमचा आन्सर जे आहे ते तुम्ही चॅट बॉक्समध्ये पण देऊ शकता.
Yep, that is okay with me. If you wanted to chat, you can put your answer over there. No. Guys, can I take it forward? I think the population is not interested. Okay, I will take it forward by next question. Okay, so let us suppose that you are a manager in certain banks and you want to detect some fraud. Okay, and you want to approve or deny the loan for particular customer, incoming customer. Okay, so what are the models or what are the key attributes that you are going to consider on this such type of problem?
We can use ANN.
Okay, why ANN?
There may be points that we can take in consideration, that occupation, income. So we can, म्हणजे आपण ते जे व्हेरिएबल्स आहेत त्यांना वेटेज असाइन करून मग डिसिजन घेऊ शकतो की आपण त्यांना लोन अप्रूव्ह करायचं की नाही.
Okay, that's great, Pooja. I think one student is interested in lecture, right? All are like they are not interested. That's what I am thinking. Okay, guys. So let's have another case. Okay, see, guys, why I am asking this case, because in data science there may be a lot of case, and you don't know what are the key techniques that have been used over there. Okay, so you need to start from scratch. You need to understand the business intuition behind the problem, and then you have to build your model. You directly can't build your model. So you need to understand the situations. Okay. So let us suppose I will take one example from your textbook. Okay. So you might have heard about this example. Okay. Let us suppose that one soft drink company wants to introduce a new soft drink in the market. Okay. And the company have collected data on two variable, that is one is purchasing likelihood and taste likelihood. Okay, so these are the two variable. So what type of model we can build using such type of data? Anyone want to go with? Okay guys, I think I should have to start with my presentation. Okay, I don't think you're getting my point. Okay. Okay, so I'm not going to take complete part of data science, how we can use Python in the data science. So for the today's session, I will be considering one small part from the data science field. Okay, so that is related to unsupervised learning techniques. So can anyone just tell me what is the supervised and unsupervised learning techniques? Hello.
Hello, sir.
Yeah, go on.
Supervised learning algorithms are trained using labeled data, and unsupervised learning algorithms are trained using unlabeled data. In
Okay,
supervised
Suraj.
learning, input is provided to the model.
Yeah, that's great. So I think you have no. Okay, so basically see in what happens in supervised learning. Okay, so there is one component who is supervising you. Okay, so in supervised learning you have certain information regarding to the final outcome. Okay, so you know the final outcome, what will be our final outcome. So let us suppose that you are considering certain classification technique. Sorry. Hello. Sorry. There is some background noise. Okay. So guys, see, in supervised learning, what will happen? There is certain label data. There is certain instances which are supervising your model. Okay. Let us suppose that if you take a classification techniques, okay, like logistic regression. Okay. So logistic regression have binary data. Okay. So the binary classes is nothing but supervised one. Okay. So these classes are our final outcome. So we know that what are our final outcomes from the data. We know what will be our final. Okay, that's calling it as supervised learning. Okay, here is some instances are present for supervising you, and in unsupervised learning there is no such instances. Okay, so that's the unsupervised learning. Okay, so where we are just doing some techniques or analyzing the data using random techniques. Okay, so where we don't know what will be our final outcome. Okay, so see, the unsupervised learning techniques are core part of initial analysis in financial institutions. Okay, so there are a lot of fields where we can use unsupervised learning. Okay, so let me share my presentation. Sorry. Is my screen is visible?
No, sir.
No, sir.
No, sir.
Just a minute. Now?
Yes, sir.
Yes, sir.
Hello?
स्क्रीन दिसत होती सचिन सर, आता परत बंद झाली.
Okay.
No.
Let me share again.
हा दिसते आता.
Is it visible? Okay,
Yes,
just
yes.
a minute. Can you see my presentation?
Not presentation. Okay, it's fine now. Yes.
Okay, so guys, just I am focusing on unsupervised learning technique. So that will be, I am giving it is named as data reduction technique or clustering technique. Okay, so here we don't know the data. Sorry, we don't know the instances. What will be our final outcome? Okay, so I will walk you through my presentations, and then we are going to code some of the techniques from clustering, okay, in Python. Okay, so this is my outline of presentation. So we are going to see what is data reduction, what is clustering, some of the methods of clustering, okay, and then I have put some slide on references. Okay, so see guys, I think what I'm talking about, the data science. Okay, so data science is a interdisciplinary field that uses the scientific methods, process, algorithms, and system to extract the knowledge insight from structured and unstructured data. And why we are going to deal with some structured and unstructured data, we need to apply our knowledge, actionable insight from data across the broad range of application domains. Okay, so there are broad range of application domain where we have to use the data science techniques. Okay, so that's why we are doing the study over here. Okay, so see, data science is related to data mining, machine learning, and big data. So I am dividing in these three fields. Okay, so these are the most advanced field currently we have. Okay, where a lot of advances are happening in current days. Okay, so data mining is one of the things, machine learning, big data analytics. So I will move to the next slide. So I think you have heard about this data reduction. So we can reduce our data by two techniques. Either we can reduce our dimension or we can reduce our object. So in reducing dimension, we can use PCA factor analysis. I think you have know about this. Okay. Again, we have feature selection. Okay, and in reducing object we can use the clustering technique. So I am going to focus on these. I think this you have already learned in your multivariate analysis paper, okay, who are in first year and second year. Okay. Guys, can anyone just tell how we can use PCA or how we can reduce the dimension using PCA and factor analysis and feature selection? Hello. Yes, anyone? Can anyone tell me what is PCA? See
Principal
guys, this will
component
not,
analysis.
I know the long form. I just wanted what we are doing in PCA.
त्यामध्ये डेटामध्ये आपण डेटामधलं कोरिलेशन आणि पॅटर्न चेक करून डेटा रिड्यूस करतो.
Okay, so how we are reducing the data? So let me tell you guys, so what is happening in PCA. Is my screen is visible?
Yes, sir.
Okay, so let us suppose that we have two variable x1 and x2. Okay, now and we have certain y. Okay, we have to predict this variable. Okay, so now what PCA does? Okay, so let us suppose that I want to predict y. Just tell me what it is doing. Guys, so I have just taken a two-dimensional array. Okay, so I am not going for multi-dimension. So PCA is dealing with multi-dimensions. Okay, okay, so let me tell you guys, so what is PCA doing? So let us suppose that this will be our x1 and x2. Okay, so let us suppose that we are defining P1 as a PCA1. Okay, so P1 is nothing but what is your linear combination for P1 principal component? Hello. Sorry guys, can anyone tell? Please be talkative, guys. If you are not going to talk, I am not getting whether you are understanding the concept or not. Okay, so just talk something, whether it is wrong or right, we can decide it after. Okay, so let us suppose that it will be L1 into x1 plus L2 into x2. Okay, this is our linear combination for PCA. What is L1 and L2 here? Can anyone tell me what is L1 and L2? Hello. Guys, there are a lot of people, but no one wants to talk. Is there any issue?
Hello, sir.
Yeah, are you getting my point? Yes, go on. What is your name?
Sir, actually, we are student of MSc first, and we have not gone through yet, sir, through PCA.
Okay, so are there are some students from second year?
Yes, sir.
So I think they have gone through this, right? Okay, so let me tell you guys. So L1 and L2 is nothing but your eigenvalue. So anyone tell me what is mean by eigenvalues? What is physical interpretation of eigenvalues? So a lot of people will say that L1 is nothing but variance of first principal component, right? Is it correct? Sorry, L1 and L2 are eigenvectors. Sorry, I am missing it. Okay. And variance of first principal component is nothing but your first eigenvalues, right? So guys, see, in principal component, what we are doing. So let us suppose that we have two variable x1 and x2, and we want the maximum variation from the data, which will predict this y. Okay. So what we are doing, we are forming the orthogonal component. So orthogonal is nothing but like we are forming the independent component. Okay, let us suppose that we have formed two components, that is p1 and p2. Okay, so we are taking two linear combination of this x1 and x2 such that that linear combination will be independent of each other. So p1 will be the one linear combination and p2 will be the other linear combination. Okay, so I am representing a p1. P1 is nothing but like this L1 x into L2 x. Okay, so now we can use this linear combination. Why we can use the linear combination? Because it consists some part of x1 and some part of x2, and it will define the maximum variation from this data. Okay, so anyway, see, if you are building the model, if you are building the regression model, if you are building the ANOVA model, okay, so what these models are related to? So these models are related to variance in the data. Okay, so if you go to the linear regression, there are terms like regression sum of square, error sum of square. Then there are terms like total sum of square, right? In ANOVA, there are same terms, right? So these techniques are dealing with variance of the data. Okay, so what we have to do for predicting such type of instances y, we need to capture the maximum variation from the data. Okay, so that's why we have come up with the principal component. So what principal component does? So principal component captures the variation from these two variables, okay, and present it as a single variable. So principal component 1 is nothing but linear combination of x1 and x2 such that it will bears the maximum variation from x1 and x2. Okay, let us suppose that it will be 80%. So principal component first will describe the 80% of variation of the data. Okay, that's why we are going to use this combination for predicting this y. So y is nothing but beta 1 into some p1, sorry, beta I into pi. Okay, epsilon. So this will be our model. Okay, so principal component reduce dimension in terms of linear combination. Okay, so principal component considers the linear combination of the data to reduce the dimension. Okay, so that's the one thing. I will go to the again to the presentation. Is it visible, guys?
No, sir.
Just a minute. Now?
Yes.
Okay. So I'm saying that this is reducing the dimension. Why it is reducing the dimension? Let us we have seen the example. There are two variables. Okay. So we are considering considering the variable which is the first PCA. That will be a single linear combination. Okay. So it will reduce the number of variable from the data. Same for factor analysis. And this is one feature selection. I think at least for these concepts, student have no feature selection. Can anyone tell me what are the methods, different method for feature selection? Guys, feature selection is nothing but variable selection, guys. If you are aware of this. Okay, so I will take it forward, guys. Okay, so see, there are different techniques like forward, backward selection. Okay, then stepwise is there. Okay, you can select by importance of variable. Okay, you can select by random forest decision tree. So these are the some feature selection techniques. So what we are doing in feature selection, we are selecting the feature which will have maximum impact on our response. Okay, so these two techniques are reducing the dimension. So let us suppose that we have to reduce the object. Okay, so then we are going to use the clustering. So why we are using clustering? We have to reduce our object in the sense we have to reduce our customer or we have to reduce our applicant. Okay, so what is clustering? Clustering is nothing but grouping process. Okay, so it will group the data into different classes or clusters so that the object within the cluster have high similarity in comparison to another objects. Okay, so let us suppose that we have group of objects. Okay, then that group of object have high similarity in between. Okay, so again, cluster is also called as data segmentation. Okay, clustering is also called as data segmentation. So guys, see, so this is the one of the biggest technique which will used in financial industries, data segmentation. Okay, so for these exercise they have separate projects. Okay, data segmentation. So this is a broader sense. Clustering is nothing but statistical data segmentation methods. Okay, so let me tell you, give you some idea about data segmentation. Okay, so there are two type of data segmentation techniques. One is behavioral data segmentation and other is statistical data segmentation. So clustering is nothing but part of statistical data segmentation. So what will happen in behavioral segmentation? So guys, you are saying that in your Facebook or in your Google, there are some promotion messages. Okay, so you will get that like if you are purchasing something on different sites, you will get the like you will get the advertisement related to that objects. Okay, so let us suppose that you are buying a milk, you are getting the advertisement related to tea powder, and you are getting the advertisement related to sugar. Okay, so why you are getting that? So in background, if you are purchasing something online, okay, in background there are some engines are going on. So that engines, what they have does, they are just grouping the customer on their purchasing behavior. Okay, so this is one technique where you are capturing the behavior of certain customer and you are grouping that customer into certain groups. Okay, so this is the part of behavioral segmentation. Okay, so you are just capturing the purchasing behavior or some different behavior, or you can capture psychological behavior as well. Okay, so this is the one part of segmentation, and another part is clustering. So see what happens in behavioral segmentation. In data, we are just capturing the pattern. So we are just capturing the behaviors of the customers. Okay, but we don't have any statistical evidence around that. So clustering is the technique where we have strong statistical evidence why we are grouping the certain customer in the particular group. So that's why the clustering is important in data segmentation. Because if you see in financial industries, if you want to offer a credit card to certain customer, okay, so what will be the range of that credit card? Okay, so what will be the amount of credit for a particular customer, that will be going to decide on such type of segmentation. Okay, so if you sorry, if you just go with the behavioral segmentation, then it will not give a concrete idea about the customer. Okay, so that's why we are using a statistical segmentation. So clustering is one of the technique, okay, that will divide the data into segments. Okay, so that's why in financial industries, clustering is more important ADA technique, okay, or data segmentation technique. So it is called as unsupervised learning technique. So why it is unsupervised? Again, we don't know what will be the outcome of the data. Okay, so we are just going to capture some pattern or similarity measures from the data, and we are going to group the cluster. Okay, so next, I think, what are the application of these techniques? Okay, so how we can use this technique and where we can use the techniques. Okay, so these are the some application of clustering. So let us consider one by one. In biology, see your kingdoms, phylums, classes, order, families. These are divided using the clustering technique. Okay, so there are some patterns or there are some characteristics for each kingdoms and phylums, okay, on which we are going to do the grouping of the living things, right? So that is in biology. In information retrieval, you can cluster the documents. Okay, different documents are clustered together. Okay, in land identification, if you want to identify the similar land to use, okay, so let us suppose that if you are cultivating certain crop, okay, and if you want a similar land which will be present currently for cultivation, okay, so you can identify such lands by clustering. Okay, then marketing data is there. So if you discover distinct group in their customer basis, okay, so in marketing data, see, I have taken one example uh, before the starting presentation. Okay, so I am saying that there is one soft drink want to launch their soft drink market. Okay, so and they have collected data on two variable like purchasing likelihood and purchasing likelihood and taste likelihood. Okay, so clustering helps such type of problems, where we can use the clustering and we can group the customers and we can make the strategies around that customer. Okay, again, we can use in city planning, earthquake, climate, and economical science. Okay, so these are the some application of clustering. Again, what is the requirement of clustering? Okay, so guys, can anyone tell, can we use clustering, any technique of clustering while analyzing the data? Hello guys. Hello. Guys, can anyone tell me?
There are some techniques: centroid clustering, density clustering. connectivity clustering.
So, Suraj, let's take one example, that soft drink company. Okay, so certain company wants to introduce their soft drink in the market. Okay, in such type of situation, can we use any technique that we want? Let us suppose that I have a bunch of technique. Okay, let us suppose that I have hierarchical clustering, we have optics clustering, we have agglomerative clustering. Okay, we have k-means, k-medile, db scan. How we can decide which technique is used for such type of data? That is my question. Are you getting my point? Okay, so can you tell me, guys? So I will take it forward. So see, in data science, while using a clustering technique, there are certain requirements for clustering. Okay, so how our clustering algorithm should be? Okay, so first requirement is nothing but scalability. Okay, so our clustering algorithm should be scalable. If you are going to use the clustering algorithm for large data set, then it should be a adaptive one. Okay, so this is the part related to scalability. So your clustering algorithm should be adaptive one. Okay, then second is nothing but ability to deal with different type of. See, guys, if you consider our data, then there might be a different type of attributes. Some are numerical attributes, some are like a factor attribute, some are the character attribute. Okay, so our clustering algorithm should have ability to deal with different type of data attributes. Okay, so that is one requirement regarding to clustering. Okay, then again, the clustering algorithm should discover cluster of arbitrary shape. Okay, so let us suppose that if you have large data, then clustering algorithm should discover any arbitrary shape of cluster. Okay, so arbitrary in the sense, if you have fixed the size. Okay, so 100 number of customers should be in one cluster, and in another cluster there may be different size. Okay, so any arbitrary size of cluster should be formed, okay, by using cluster algorithm. So that is one requirement. Okay, again, the algorithm should have minimum requirement for domain knowledge and input parameter. Okay, so like, see guys, there are some algorithm which will be depends on parameter like k-means clustering. Okay, so there you have to decide your k. Okay, so you need the domain knowledge how we can decide the input parameter. Okay, so clustering algorithm should be like that. There should be certain techniques for defining such type of parameters. So that is one requirement related to clustering. And again, last one is able to deal with noise and outlier. So we have to deal with noise and outlier with the clustering. Okay, so there are certain clustering like k-means. Okay, if there is an outlier in the data, then this will be affected. Okay, so that's why again we need a clustering algorithm which will deal with noise and outlier data. Okay, so these are the certain requirements for clustering algorithm. Okay, again, so what are the data types in clustering? So here I have two data matrices. One is object variable structure and another one is dissimilarity. Okay, so you can pass either. Okay, you can pass the dissimilarity measure matrix or you can pass the data matrix to the clustering algorithm. Okay, so I will pass this Okay, I will don't go deeper into this. Okay, I will take it forward. Okay, so these are the variables, some type of attribute, and we need to compute the dissimilarity on the basis of such type of attribute. Okay, so in further presentation we will going to see how we can compute the dissimilarity measure. Okay, so see, I think for numeric variable, you can compute the mean absolute deviation, you can compute the standard measurement, okay, or z-score, you can compute the modified z-score, okay, and you can classify the variables. Okay, again you can use some type of distance measures. So these are the some distance measure, mean Koisky distance, okay, then Manhattan distance. Okay, so you can compute the distance in between ijth object, okay, and you can cluster. So for which object, ijth object, the cluster distance is minimum, okay, we are going to cluster that object or on the basis of requirement. Okay, then there are certain properties of distance. Okay, these are the properties of distance. Again, see, if you have binary variable, you can compute the frequency table like this, and you can compute the distance on the basis of this formula. Okay, for there are some symmetric binary variable or symmetric binary variable. Okay, so I will share the material related to symmetric and asymmetric binary variable after this presentation. Okay, so for on the basis of this formula, you can compute the distance and you can compute the ijth variable on the basis of this. Okay, then again we have nominal variable. So in nominal variable, you can use the distance formula like this, p minus m by p, where m is nothing but number of matches and p is nothing but total number of variables. Okay, so this we can use. Again, there are some multinomial states. Okay, so for this variable we can have certain measures. Okay, again there are some ordinal variable where we can use such type of formula, where RIF is nothing but a rank for a particular variable. Okay, again if you have mixed the type of variable, okay, then we can compute the distance using such type of formula. Okay, okay, so these are the some major categories of clustering. Okay, partitioning method, where partitioning method includes k-means, k-medoid, Clara, Clarence, etc. Okay, I think this you have studied hierarchical method. Okay, in which Agnes is one single complete average linkage method. Okay, so these are agglomerative clustering method. Diana is one. Okay, divisive clustering method. Then we have density based clustering method like dbScan and denview. Okay, then we have grid search based method. Okay, then we have model based method. Okay, so these are the some major categories of clustering. Okay, so we are going to see the Python codes for some techniques. Okay, so I think this you have studied in hierarchical clustering. What we are going to do, we are going to combine on the basis of similarity measures. Okay, so like we are taking the minimum distance in each group, okay, or in each object, and we are collecting these objects as one cluster, and we are going to forward in agglomerative. In divisive, what we are going to do, we are going to separate or group our entire going to start with whole data, and we are going to divide the object on the basis of dissimilarity or similarity measure. Okay, then these are the some special type of clustering. So in affinity propagation, what we are going to do, we are finding the examplers or example that best summarize the data. So let us suppose that if you have certain data and if you want to summarize the data in best groups, okay, so these are the certain techniques where we are finding the example, best summarizing example to cluster or to make the groups. Okay, so this algorithm based on two matrices. One is responsibility matrix and another one is availability matrix. Okay, so I will share the material regarding to this. Okay, so again there are some clustering, bridge clustering. Okay, so this is known as balanced iterative reducing and clustering using hierarchies. Okay, so it involves the constructing tree structure from which cluster centroid are extracted. So see, in such type of techniques, what we are going to do, we are going to extract the cluster centroid. Okay, then again we have dbscan density based spatial clustering of application with noise. So in dbscan what we are going to do, we are finding the dense part of the data. Okay, so we are finding the instances on the basis of some neighborhood techniques. Okay, where we have maximum density. Okay, so we are finding the maximum density area in dbscan. Okay, again, so there are some modified clustering techniques like mini batch k means clustering, mean shift clustering, optics clustering. Okay, that is ordering point to identify the clustering structure, and we have some Gaussian mixture model. So I think you don't have heard about the distributional model for clustering. Okay, so these are some clustering technique. So I will go to the Python code for this. Okay, let me share the screen. Is it visible, guys?
Yes, sir.
Python code is visible?
Yes.
Okay. So guys, we are going to see some of the techniques. Okay. So I will going to explain the code. Okay. So see, I think that this is this library which I am to use, that is scikit-learn. Okay, I think a lot of people may know about this. Okay, and this is our extensive library where we have different algorithm for clustering, for modeling techniques. Okay, so you can use this one. Okay, so again, I am checking the version of this library. So why we are checking the version? So see, guys, there are certain algorithms which are like restricted to version. Okay, so that's why we are checking the version. Okay, so here if you run this code, so I'm using this version of sklearn. Okay, 0.241. Okay, so in this version it is available. Okay, then I'm creating some synthetic data for classification. Okay, so what I'm doing, I'm importing these libraries. Okay, then I'm defining the data set or the random data for clustering. Okay, where I am creating 100 instances on two future. Okay, and n informative is nothing but how many informative objects or how many informative variable in the data set. Again, how many redundant variable which don't have any impact on response. Okay, how many clusters as per classes. Okay, and what are the random states. Okay, so that's I am going to define. Again, I'm just for my understanding. Okay, what are the groups forming or in the synthetic data? I'm just plotting that group. Okay, so let me run this code. So let us see what will be the output. Okay, so guys, see, if you are running this code, you get this output. So these are the classes with respect to first one label, and this will be 0 label. Let me show you the X. Okay. See guys, this is our X. Okay, so if you see the shape, so we are constructing the X matrix. Okay, then if you see the Y, so this is my Y. So we have a 0, 1 label. Okay, so this is, I have created a one synthetic data, okay, on which we are going to do the clustering algorithm. Okay. Okay, so first clustering is nothing but affinity propagation. Yeah. So again, the code is same, structure is same. Okay, so I am going to take some synthetic sample. Okay, and again I am going to use the affinity propagation model where we are using damping factor. Okay, and again we are fitting that model. Okay, and using it for clustering, and we are plotting those models. Okay, so if you run this code, so see guys, you are getting this image. This is showing the different cluster. Okay, each color presenting the different cluster. So if you see the data, okay, if you see the image, these are the observation in green. Okay, so these are the observation which is merged together. Okay, there are some blue lines. Okay, blue dots. Okay, here are some blue dots. Okay, so this will belongs to the one cluster. Okay, again on the basis of color code we can identify the clusters. Okay, so this is one algorithm, affinity propagation. You can see the code. I will share this code. Okay, if you want to go deeper into the model, okay, you can search around each and every comment over there. Okay, so this is one. Again, this is well-known agglomerative clustering. The syntax is again same. Okay, so I am taking the synthetic data. Again, there is I am using the clustering method. Okay, and I am plotting those clusters. Okay, so see, I have defined the n cluster as 4, so we are getting the cluster 4. Okay, so same type of algorithm I have mentioned, same type of code I have mentioned for understanding. Okay, so we can use different code for defining the cluster. Okay, so why I'm mentioning this, because you can understand better if we have same structure of code. Okay, now I just wanted to make some changes. Let us suppose that guys, if we are going to change this parameter n cluster as well. Okay, so if you run this code now, okay guys, what will happening? It is giving a 4 cluster in different format. Okay, so our data is changing here. Okay, so just play with this parameter guys. Okay, and see how which structure is getting for your cluster. Okay, so again we have bridge clustering, the code is same. Okay, we are getting this. If you are going to change the cluster identity, cluster classes, okay, you will get this. It will change the structures. Okay, so I think there is not much to define on Python code. Okay, I am not going to explain each and every step of Python code because it is more explanative. Okay, I have commented each and every section by this defining data set, defining model. Okay, I have put there. Okay, you can go through this code and you can run, and if you have any doubts in this, you can reach out to me. Okay, again if you see the k-means clustering, you can get this. If you going to increase this parameter, you will get this. Okay. Again, mini batch clustering. In mini batch, what will happen? So guys, see, k-means clustering taking whole data set, and we are defining some centroid. Okay, and on the basis of that centroid, we are going to cluster our objects. Okay, what will happen in mini batch k-means clustering? We are considering the mini batches of data. Okay, we are not taking whole data in mini batch clustering. Okay, so here what will happen? It will like adapt with the batches. Okay, so your centroid will be adapted with respect to batches, and you are going to cluster the objects on the basis of different batches. Okay, so in mini batch we are considering the small batches. It will not give much difference for synthetic data, but if you are going to deal with real life data, it will definitely going to show the difference. Okay, so I have taken here a synthetic data. That's why it is not showing much difference in each technique. Okay, so if you see this, if you see this algorithm, k-means, okay, if you see this and if you see this, I think this is similar. Okay, it is not showing much difference, just color code are changed. For synthetic data, it will not show any differences, but if you are going to take the real life data, then definitely mini batch and k-means will show you difference. Okay, again, mean shift. In mean shift, what is going to do? We are going to adapt our centroids. Okay, in each step, our centroids will be adapted. Okay. So it will take some time, just a minute. Okay, so see, here in mini batch we don't need to define, okay, the cluster. Okay, I have didn't define anywhere cluster. Okay, so it will automatically update itself and find the cluster centroid. Okay, and define the cluster. Here if you see, there are 3 cluster. If you see in mini batch, okay, there are 2 cluster. Okay, then we have optics clustering. So optics is nothing but it is modified of DB scan. We are going to check the spectrum. We are going to classify on the basis of that. Okay, so we are computing the spectral density here. Okay, so if you see this for spectral density around the certain points. Okay, if you're saying this, is it visible, guys? Hello.
Yes.
Okay, thanks. Again, same for spectral density. Okay. Again, okay, so this is one of the most important. It is nothing but Gaussian mixture model. Okay, so what is doing this Gaussian mixture model will define the probability distribution for the data, and on the basis of prediction of probability distribution we are going to classify our data. Okay, so if you run this, see guys, in each step, if you are seeing the cluster are more what similar, okay, in each cluster. Okay, why it is showing? Because I am generating some random synthetic data and I'm using the clustering. Okay, so that's why it is showing the same pattern. So if you take any random real life data, this will definitely going to show a different pattern. Okay, so in Gaussian mixture model, okay, so these are the financial model, Gaussian mixture model. Okay, so it is used for creating a customer segment in financial data. Okay, so this is a distributional based object where we are going to define the distribution for each prediction variable at the basis of what we are going to do. We are going to group together the objects which have similar distribution. Okay, so this is most important in financial industries. Okay, so if you run this code, you will get the similar objects. Okay, so guys, I think this is pretty much what I have done. Okay, so if you have any questions around the course or around anything, any concept, you can ask me. Hello. Guys, session is open for I think questions. If you have any questions, you can chat down over there. Okay, not related to this, like not related to this lecture only. If you have any question related to data science, related to how we are working in industries, you can ask me. I think, see guys, I have given you high level of overview of clustering technique, because defining each and every term in this short time, it will not be possible for me. Okay, because the methods which I have mentioned, that have a lot of mathematics behind them. Okay, so if you go deeper into the mathematics, okay, then you might get the idea what these algorithms are doing. Okay, so that's why I have just given an overview of these techniques. And if you want to see the application, industrial application of these techniques, how we can going to use the techniques, okay, I will show you one platform. Pritam, can we just stop the recording, because this is confidential
Okay.
material. We can't